All right, I'm going to talk a little bit through the day one worksheet on graphing our polar graphs, both the points and some of the simpler equations here. So the first ones, we were plotting the points just on the grid. Hopefully they weren't too bad. It is kind of like graphing, an XY coordinate point, but obviously these are definitely different and they take a little getting used to here. Again, our points are r comma theta here. Instead of xy, it's r comma theta. So the first number here is the r value. That's how far it is away from the pole. And then the second value is the angle measure, that theta value. So for point A, if we're at 3 pi over 4, that means we're right here on this line right here at that angle 3 pi over 4. And it's 4 units away from the center, the pole. So 1, 2, 3, 4. At 2 pi over 3 for point B, here is 2 pi over 3. But notice that R value is negative. So all the positives would be going out towards 2 pi over 3. Our negatives go in the opposite direction. So 1, 2, 3 in the opposite direction. That's why point B is over here, actually more corresponding to that 5 pi over 3, just because it's in that negative R direction. Next point, if the angle is negative, we're going, if this is positive pi over 6, that goes in the counterclockwise direction. Negative pi over 6 goes in the clockwise direction. And then we're along that axis right here, so we are 1, 2 away from the pole there. For point D, negative 11 pi over 6. Again, positive 11 pi over 6 goes this way. Negative 11 pi over 6 would be along this pi over 6 axis right here. But they're both negative, so that means the R value is negative as well. So instead of being along here, right here would be positive 5. But we have negative 5, so we're going 1, 2, 3, 4, 5. That's why my point D is here. And then point E is 6, 0. So again, our angle is 0 right here. And then 6, 0 would be right here. It kind of corresponds almost to really just a rectangular point, 6, 0 right there. And then if I have 0, negative 3 pi over 4. So positive 3 pi over 4 is here. Negative 3 pi over 4 would be right here at the 5 pi over 4. But an R value of 0 would put me right at the pole, at the center there. So that's just graphing the points. For the rest of these here, graphing kind of using those patterns that we looked at in the video. So again, we knew now that this value right here, that value in front, we'll call that our A value right now, that's really how far away the graph will go from the pole right there. That ends up being really the diameter of our circle. Really the reason is think about what's the maximum value that cosine could be. We know, again, the maximum value for cosine is 1. The minimum value would be negative 1. So if we had the cosine, if the cosine was 1, 4 times 1 would put us at 4. And we know that the cosine is 1 when the angle is 0. So if I put in 0, it's going to be right here at 4, because 4 times 1 would give us the 4. If then I went to pi over 2. Cosine of pi over 2 is 0. 4 times 0 would be 0. If I did the cosine of pi is negative 1. 4 times negative 1 would be negative 4. So this is the axis along pi, but if I went negative 4, it goes in the other direction, so it's back here. And then 3 pi over 2, once again, is 0. Just to think about where some of those other points would be, we want to really think about where is the cosine 1/2. So we know the cosine is 1/2, really both at pi over 3 and 5 pi over 3 here. So if I did 4 times 1/2, so 4 times the cosine of pi over 3 would be 4 times 1/2. That'd be 4 times 2. We would have, or sorry, 4 times a half would be 2. We would have our point here at 2 and our point here at 2. Again, another way to think about it, we know it's going to be symmetric to that horizontal axis right there. So looking at negative 2 sine of theta, again, really similar here, but this one is sine. So we know, again, still our maximum value for the sine is 1. Minimum value would be negative 1. And we know that the sine is 1 at pi over 2. So if you put in the sine of pi over 2 and say, okay, that's negative 2 times 1, right there, that would be negative 2. So at pi over 2, we would graph it at negative 2. I'll go back to 0. Sine of 0 is 0, so negative 2 times 0 would be 0. We did the pi over 2. pi, sine of pi is 0, so times negative 2 is 0. And then if I went to 3 pi over 2, sine of 3 pi over 2 is negative 1. Negative 2 times negative 1 gives us 2, so that gives us that point right there. Again, think about where is the sine 1/2. We can think through those points there. So we know the sine is 1/2 at pi over 6 and 5 pi over 6. But if I put in the 1/2, so sine of pi over 6 would be 1/2. Negative 2 times 1/2 would give us negative 1. So that's why we are right here. And then same thing at 5 pi over 6, it'd be negative 1 here. So that can help us figure out the rest of those points. These again are going to be really similar. You'll notice again some of the patterns along the way here. If it's positive 4 cosine theta, it's going for the diameter is 4 and it's to the right over here. If it's negative 4 cosine of theta, again notice it's still symmetric to the horizontal axis right here, but it's to the left hand side right here. Again, if I put in cosine of 0. Cosine of 0 is 1, but for negative 4 times 1 would put us at negative 4. And again, we think about our half points along the way as well, but we're multiplying by a negative, so that's why it went in the negative direction there. So r equals 5 sine of theta. Again, you'll notice that if it's negative 2 sine of theta, it's symmetric about the vertical axis right here when it's the sine, but when it's negative, when it's negative, it's going down below. And when it's positive, it's going up. Notice that the diameter of our circle here is 5. Diameter of this circle here is 2. Again, those are just some good patterns that can kind of help you graph them a little bit quicker. So hopefully this one went okay for you. Please let me know if there are any questions on them. Thanks.